Welcome in the arena. My name is Allyson Klein. We're coming to you from OCP Summit in San Jose, and I am delighted to be with Kevin Coakley, CEO of CelLink. Welcome.
Thank you.
So, Kevin, before we even get started, CelLink is a new name for a lot of the people that watch this show. Why don't you go ahead and introduce the company and the background that you and the team have in terms of delivering really innovative technology?
Yeah, thanks for having me. It's great to talk about CelLink with the data center community. CelLink started as a concept for the back of a solar panel. Originally, we set out to figure out how to make solar panels more efficient by moving the wiring from the front to the back of the panel. And when we started developing that technology, we realized that there wasn't an existing solution out there that could transfer the current that you need to transfer inside a solar panel. So we basically invented a new manufacturing technology that enables very high currents to be transmitted with a very flat wiring element. And so that's the value proposition and origin of CelLink.
Now, I know that you've had success in the automotive arena with these core capabilities. Here we are at OCP. The focus point is AI factories. Tell me about why you think this is such a cool capability when you think about the power challenges in AI.
Yeah, well, thanks for the segue, and maybe to complete the origin story, around 2018, we met some folks in the automotive industry, and they said, if you can connect solar cells with your technology, why not battery cells? So the name CelLink actually still applies. And so we mastered how to carry very high current within a battery array in an electric vehicle. And what we see happening now is that the exact same problem is popping up in the data center world, where you need to get very high currents into 0.8 volt GPUs to make them compute. And the challenge becomes, how do you get the power there most efficiently? How do you burn the least amount of watts in the transport of the power? And so that analogy is almost a perfect fit for us as we go from automotive to data centers.
And when you look at what's going on in data centers today, we're talking about gigawatt class facilities, megawatt class racks. How has the design point shifted to open the door for something like CelLink?
Yeah, great question. The higher and higher power usage requirements also come with a stronger space requirement. That these GPU manufacturers and data center manufacturers want to pack their compute into a smaller and smaller footprint, mainly so that they can get the signals from A to B without having the signals get lost. But as you condense that entire rack, you need to deliver even more power into a tight space. And that's where our product comes in, because it's very flat. So all of that precious space that's gobbled up by traditional round wire harnesses can now be replaced with a flat power delivery element that performs the same function but with much less space.
You've worked with some of the largest auto manufacturers on the planet. Tell me a little bit about what that teaches you about starting to engage with some of the largest manufacturers on the planet, those that are delivering compute infrastructure.
Yeah, great question. And the number one word that comes to mind is quality. And getting to automotive quality is a trial by fire. My hair was brown when I started CelLink. It's now gray. And you know, we learned a lot in scaling up this technology for automotive. And I'm happy to say that we've had a lot of success too. We have over 3 million parts in vehicles today.
Impressive.
Yeah. Only 19 have failed. So that's a number I keep etched into my brain because we want that to stay low. But that's an extremely low failure rate for our first, foray into automotive. And now we're planning to transfer that quality knowledge into the server space.
Now, the thin and flexible design I saw it. It's very cool to look at. But tell me about why you think this could be innovative in terms of the entire system design and really the entire rack design for customers.
Well, the product we're launching today is called the PowerPlane, and it integrates power delivery and cooling into a single product.
Wow.
So that you can now...
You just tackled that too, huh?
Yeah. And ironically, the same manufacturing process can be used to make both. So this is not a pivot or a reinvention. This is an extension of what we already do. But because we can combine these things, it allows us to open up what's called backside power delivery into a server architecture. So instead of having to run wires to the top of a motherboard, you can now deliver power from the bottom, and you can cool from the bottom, which opens up the top to be used for signaling only. And so that's a big sort of architectural shift that we enable with this product we call the PowerPlane.
That's really cool. We're at OCP Summit, and when you're talking, I think about scalability and efficiency, and the core tenets of OCP, 2 of the 5. How did those inspire the way your engineering team took on this design?
Yeah, great question. I think what's unique about us is we're a company of doers, and that starts with me starting the company on my own workbench, and we believe in trialing, experimenting, testing over and over again, iteratively until we have the perfect solution. And I think that's a unique thing that I see as we enter into the data center world, because a lot of the data center universe has evolved into CAD drawings being sent from one company to another and saying, hey, just figure out how to make it. I drew it, you make it. We combine, we say, we don't just draw these things in CAD. We learn how to make them. We learn how to manufacture them. We learn how to get up that learning curve so that when we ship, it's a product that's going to work every time. And if you don't couple those together, in my opinion, you are asking for headaches in the field. So that's been a real, I think, adage for us that's worked well in automotive, and now we're bringing that into the data center world too.
Now, OCP issued an open letter to the community about the need to move faster, the need to innovate together around open standards. They also had something interesting in there about robotic-assisted manufacturing. Tell me why your technology is such an enabler of making that happen.
Yeah, thanks for asking that. Our technology supplants something that is a long-standing challenge in the automation world, which is handling wire harnessing with a robot. There are basically bloopers videos out there that you can watch of robots trying to do this and not succeeding. Our product is flat, and so that's a starting point to enable a robot to work with it, and it's a defined layout. So again, if you want to use a robot, you need a layout that is precise and controlled. Wire harnesses flop all over the place. So by putting this product into a defined layout that's flat, we can now enable robots to do more of the work. And with that comes repeatability of process. Yeah.
And total efficiency in terms of the manufacturing time, I would assume.
That's right. For server manufacturers, I think both inside a tray and from rack to rack, there are lots of opportunities where we can integrate what used to be separate wires into a single sheet or panel, which then reduces the number of steps you need to make a data center connect. So that's a huge advantage of our approach too.
So, I know where this is going. This is going to be a softball question for you, but is this an incremental change, or is this something much bigger?
Well, I feel that the PowerPlane unlocks an entire architectural shift inside the server. So I would selfishly say it's a major change, a major improvement to the way these servers are designed, because now you can decouple the space around a GPU between data delivery and power delivery, and so we unlock that, which is going to be a big advantage for server manufacturers.
Now, I wanted to ask you, in terms of those benefits, there's so many that you've described. What do you think an operator experiences first? Is it density? Is it efficiency? Is it commissioning speed? Is it flexibility? What is it that comes with the first implementations?
Yeah, I think the very first problem they encounter is commissioning speed, because they're trying to get these data centers up as fast as they can, and there's just so much manual labor embedded in the production of an AI factory. That starts at the assembly of a server, where today almost all of that work is done overseas, and it's done in very specialized facilities to wire and string things together, and then those are packaged up, shipped across the ocean to a place where a construction worker is doing even more wiring of things. And so the speed of commissioning kind of suffers at every point in the supply chain by a lack of automation. And so that's something I think we would address right out off the bat with a server our data center manufacturer.
Now, obviously, you're having conversations with the data center arena here at OCP. Looking ahead, where do you see CelLink technology going? How do you expect it to make an impact or a splash, if you will?
Yeah. I think in this forum, to be able to deliver 10 kilowatts plus of power on a very flat wiring element will quite possibly revolutionize the entire way that these servers are made and designed. So that's I think going to be a very large opportunity for CelLink and a great advantage that these folks that adopt our product will get. And then longer term, I kind of go back to what we talked about earlier, which is that we've invented a manufacturing technology. Mm-hmm. So it goes beyond one product. It's a new way of making a large variety of products, each with their own value proposition. So I think in the long term, our kind of core categories of high voltage cabling, battery current collectors, the PowerPlane, you'll see that expand into 5 or 10 other things that we can do with the same technology. So, and that's what's fun for me as a CEO, is thinking about what else can we do with this and how can we interconnect the most things possible.
You know, Kevin, I talked to a lot of companies around the industry, and a lot of them have really cool foundational technologies. Some people have technologies may not be so cool, but they're enabling incredible disruption. You have both.
Yeah.
And so thank you so much. I've been so impressed ever since I first heard about this technology. Thank you so much for being on Tech Arena today, and have a fantastic time at OCP.
Thank you very much for having me. It was great.